In this video, we'll look at curvature and normal vectors. First, let's find the unit tangent vector, t, and the curvature, k, of the vector r. So in order to find the unit tangent vector, we're going to need to take the derivative of r and then divide it by its magnitude. Well, the derivative of r, the first component would be -2 sine t, and the second component would be -2 cosine t. And the magnitude of that, square each component. So we would have 4 sine squared of t and 4 cosine squared of t, and then take the square root of that quantity. We'll notice in the denominator, sine squared plus cosine squared equals 1, and the square root of 4 is 2, so that simplifies rather nicely to a unit tangent vector of negative sine t and negative cosine t. All right, and then the second thing we were going to look at was the curvature. It might be helpful to recall the formula. So curvature is the magnitude of the cross product. So that's of the acceleration vector times the velocity vector, or cross the velocity vector, over the velocity vector cubed, its magnitude. All right, so if we're going A cross V, we'll need to take the first derivative to get the velocity. We've done that up above. And then we need to take the derivative of that one more time. So then the numerator would be the magnitude of the cross product of -2 cosine t, 2 sine t, 0, and cross product times the acceleration vector, which would be -2 sine t, -2 cosine t, 0. And then if we were to find the magnitude of the velocity, looking up here, square root of 4 is 2, and then cube that. That would give us 8. And then if we were to take the cross product up above, we're going to eventually have 2 times 2, which is 4, and 2 times 2, which is 4, and then we're going to have sine squares and cosine squares. So that will leave us with a 4, and we have an 8 in the denominator. So you're going to want to check my math here and ask questions on the discussion board, which leaves us with a curvature of 1/2. All right, as mentioned, we'll take a look for questions that you might have on the discussion board.